Good evening, everyone. I'm Uma Maheshwari, Assistant Professor, Department of Electronics and Communication Engineering. Now, in this particular video lecture, I'm going to explain about the analog sensor interfacing. First, we'll be creating a dimmable LED using a potentiometer. The components required are a LED, resistor, potentiometer, jumper wires in the breadboard. In this program, we dim the LED based on the value which we read from the potentiometer. A zero value from the potentiometer is a 0 volt, and the value 1023 from the potentiometer is a 5 volt, which means we need to write a value of 255. Hence, we need to scale our read values from the potentiometer, which was between 0 to 1023 to suitably write the values from 0 to 255 using the formula, that is write value which is equal to 255 by 1023 into read value. This is creating a dimmable LED using a potentiometer by using the Arduino board. Uh, by using as a normal hardware diagram will be or drawing it over a software. So for creating a dimmable LED using a potentiometer, we'll first declaring the pins corresponds to an LED to pin 9 and a potentiometer to pin A0. So giving input potentiometer pin to A0, LED pin to 9, then we are reading the value and writing the value in order to store and write the values. Then white setup here, pin mode, that is we have to give the inputs. So, potentiometer input, LED input is given under the serial functions. Then we are going to assign the loop function. So, we read value where analog read input is taken from the read value. From the write value, will be using a LED, that is that write formula. Then analog read finally will be going for the serial print. Interfacing their sensors to the Arduino, various sensors can be interfaced with the Arduino, that is temperature sensor, light sensor, ultrasonic distance sensor, and the line sensor. Here line sensor will be called it as infrared sensor. Then interfacing temperature sensor, LM35 is a temperature sensor in which the series of the gadgets with precision integrated circuit temperature whose voltage falls directly corresponding to the centigrade temperature, where it calibrates directly in Celsius and operates from 4 volt to 30 volt. The ranges are evaluated from full minus 55 degrees Celsius to 150 degrees Celsius. Then it is suitable for remote applications, and it is also used in battery management. The pin numbers with the various functions has been displayed over here. Then the interfacing the temperature sensor in the Arduino board is also shown in the diagram. Then this is the program for interfacing the temperature sensor. We are first initializing a variable, then followed by the inputs, then void values, and finally will be going through with the loop functions. Then automatic lights with light sensor. Yeah, lights, it's nothing but a photoresistor, is a light dependent resistor. The resistance of the photoresistor decreases with increasing of the light sensitivity. So when there is light, the resistance decreases. We'll be having more current flows. So when there is no light, the resistor increases, will have less current flow in the circuit. So according to the condition, the Arduino will be having the we are having the Arduino diagram in the software. So the Arduino lights with light sensor, we are first assigning the inputs with LED pin to 9 and the brightness to 0, then the sensor pin to A0 and the sensor value to 0. Then going with the void functions, and with in the void functions we are also assigning input as well as output. Then we are going with the loop functions. In order to measure the speed of the sound using ultrasonic sensor, will use the formula of distance equal to rate to time, where rate is equal to time by distance. Here the sensor, that is trigger low, high, low sequence on the pin, which creates a high pitched ultrasonic tone was sent out from the sensor, which will go out and bounce off the first thing in front of it and back to the sensor. The sensor will output the high on the pin, and the length of the pulse in microsecond indicates the time which took to travel to the target. Then we'll measure the length of the pulse using the pulse in command. Finally, we'll convert this to miles per hour as follows, as given in the calculation. This is the Arduino board diagram of the measurement of a speed of sound using ultrasonic sensor, and this is the program. Finally, the assessment is how to measure the speed of the sound using the Arduino board. Thank you.